So hi, let me introduce myself a bit. I'm Frank, I'm a tech lead at Bol. Been all over the place, been there for 12 years. And at this moment I'm a tech lead of the optimal checkout experience. So basically leading the troops for the basket and the checkout pages and all the backend systems that are involved. Yeah, and for the keen watcher, this is an old presentation, but because by now we are no longer bol.com, we are Bol. So, yeah, and at Bol we recently did a talk about microservices because we see that the amount of microservices and the way of working has a bit exploded, and the impact of microservices, mostly the negative impact, has become really apparent, and that's what this talk is about. So basically I've just answered the question. We think it matters. So, well, oh, and that's what you get if you type my name and ask DALL-E to generate an image, which referred to another talk at the Spaces Summit, which was about IE and the great opportunities in the region, but clearly you cannot use it blindly. So, we have broken up the story, a bit of historical perspective. So, how did we even get to microservices? How this architecturally has given us challenges, how this technically has given us challenges, and we'll wrap it up giving a bit of our insights and ideas on how you might want to deal with microservices or the size of services in the future. So, growing pains. I think most bigger companies, or the big companies at this moment, started developing their systems in a time that we only had monoliths, or you had like one monolith, or you had a couple of monoliths, but basically you had a company as a system, right? The whole thing was basically deployed in one King Kong deployment, often orchestrated, and often it was deployed like once a month or something. This company grew, and this organizational growth involved that we started adding more and more business capabilities to this single system. And what you started noticing is that because we wanted to add more business capabilities to the systems, and yet all of a sudden more people on the business side, managers, product owners that wanted to add something, there was friction because everything was intertwined. And this friction was not only in the organization, right? I want to deploy this, or I want to deploy this, or my change needs your change. There were all kinds of ways that the organization was actually fighting each other. But this was also technically. So technically it was, for example, well, we had a web shop, mega big beast, and we had not Resilience4J, but its predecessor, Hystrix, there. It used observables from Netflix. So you cannot contain these changes, right? It's super hard to go gradually to a new library. Protobuf is the same. Protobuf v2 to v3, massive issues to upgrade. So it's not that you want to organize change on a functional level, you also need to organize change on a technical level. And that became harder and harder over time. And as you can imagine, all the time that you spend on basically canalizing these changes technically or functionally, that's time that you lose that you can actually make an impact. So the time that you spend on this friction actually reduces your ability to innovate. So there is an underlying cause of why this gets a friction, right? And the underlying cause is usually there's a lack of boundaries. And this lack of boundaries in turn creates a lack of autonomy. So if two parts of an application are perfectly isolated, you might say that within a monolith I can easily modify A and I can easily modify B. And if I can prove these parts are isolated, I'm largely autonomous. However, if it's one code base, this is often not the case. And the underlying problem of that is that designing and keeping things isolated is really, really hard. And what is hard here? Well, you guys. I mean, we're humans. Some of us are smarter than others. But we find it very, very hard as a group to come to make a certain decision. Everybody's opinion is valued, and because that opinion is valued, we rarely end up with making the best decision. What we end up with is making decisions that are basically the least worst for everybody. So it's the human factor that makes things really complicated in software design. So we noticed that we had problems with isolating things, and that this lack of isolation was giving problems technically and in the organization as well. So what we started doing is isolating business capabilities. So what we wanted to do is break down this monolith, right? So you have a large collections of functionality in one system, and we want to isolate these things so we can take them out. That was the idea. And our solution was microservices. Right? Micro as in you take one business capability, you isolate it, you take it out, deploy it, invoke it over the network, and that was it. So what we have here now all of a sudden is a physical boundary, where first systems lived in a single code base, and it was very easy to intertwine things. Things now live in their separate repository, probably separately deployed with separate of everything. So these things are costly. Every abstraction actually is costly, right? So if you had an interface and only one implementation, it's a tiny bit of overhead, not too useful. If you do this 1,000 times, you have 1,000 extra files. And this, like, if you project this on going from a monolith to a microservices, you have a whole lot of everything extra. So none of these things are for free. Remember, we're trying to solve a problem. We're trying to make sure we can innovate autonomously, but there are costs associated with achieving this. So it's never that you only benefit. It's always a matter of give and take. And what we choose to add a level of abstraction, and we choose to implement overhead as a solution. So now all of a sudden we went from architecture within an application, let's refer to it as software architecture, to something, a problem that needs to be solved at the landscape level. And this is where Alex will take over from me.
As if I'm solving the problems, right? No. Yeah, hi everyone. Thanks, Frank, for the nice intro into the topic. I'm Alexandra. I work as a principal tech lead at Bol in the advertising area, but I'm also really passionate about looking at our landscape as a whole and not only within my area. So I'm going to give an architectural perspective on this topic, and this is really related to how our landscape is set up right now. So I won't talk that much about solutions. I will talk about the overhead that we see due to the setup that we have. So first of all, API fragmentation. Currently we have around 1,500 different applications that are interconnected at Bol. So sometimes that translates to the fact that the consumer needs to know a lot about the internals of different services, different domains, their data models, their interfaces, and they end up consuming a lot of interfaces from the same area, let's say. So it's as if I'm a cake lover and I enter a bakery and I want to order a piece of cake and eat it, but instead of that, the bakery gives me either the ingredients or the recipe or where to find the ingredients, or even worse, I need to bake it myself based on what the bakery just told me. So of course that doesn't make me a happy cake lover. I want to just order a cake and eat it. This is a bit of what we are dealing with right now, because we looked at it also in terms of API fragmentation, and basically I look at every product at Bol or product group, that's a bundle of teams and of capabilities. How many connections are there outside of that product? So we realized that for 57 products, we have more than 8,000 connections between them. So very chatty services. And by the way, this is based on Istio connections, so only the sync connections are taken into account. But besides this, we also work a lot with BigQuery, with PubSub, async. So I think quite some high numbers. And for me, the high dependency immediately translates to slowing down innovation speed. So the attempt number one that we did, we created what was called the product APIs. So basically creating an API around multiple services that would just give you the cake. And that sounds really great. And I think it's still a great idea. So we were aiming to have more separation of concern. And of course, we wanted to limit all the breaking changes to the internals of a product and not to every consumer outside of the product. The only problem that we encountered, besides priorities and stuff like that, was the fact that the product definition is still very fluid. So it's not only the technical boundary or the functional boundary of a certain area, it also has to do with business goals that change, with team size, with maybe ego of a EM or a GPM, I don't know. But basically, it's not what we wanted in terms of functional boundaries. So now, I think we concluded that it's always a good idea to aim for well-defined functional boundaries and know what the consumer needs and what the producer can offer, but keep your functional boundaries intact no matter how the organization changes around you, because at Bol we really reorganize ourselves quite often. So that was a lesson learned. The second topic that I want to bring up is the fan-out problem. Doesn't ring any bell, it's really internal, that's how we call it. But you know, we have our web shop, and I'm curious, quick quiz time, how many endpoints do you think the web shop is connected to? Any idea? That's exactly the answer that I'm going for. You read my mind, but yeah, 300, around 300 endpoints. So I want to explain you what this problem is about. So the fact that webshop connects to more than 300 endpoints means that it's very hard for the webshop team to really keep up with all the API deprecations, but also services that split, merge, changing their APIs. It's hell for them. And it also became a huge scalability problem. So it reached a certain moment where the webshop cannot scale efficiently anymore. So this is what we think it's caused by the massive fan-out. Not only that cause, but also the fan-out. And what I mean is that for example, this is a product page, and for 2,000 requests per second, incoming requests per second, webshop actually spins up 120K requests per second only to the first dependencies, to the direct dependency. So we don't have distributed tracing, so we don't even know the real numbers throughout the landscape. So I think this is quite high. So we realized that the more fine-grained we define our services, the higher the NFRs will be, the non-functional requirements will be. So usually how we fix a high-performance requirement, or how we manage to pull it down, is either by replicating data or adding caches. And that's fine, a perfect solution, right? But of course, this comes with a lot of challenges. You need to keep the data consistent, to implement all security guidelines. It brings some operational overhead. And a really important one, experimentation becomes really hard, because you would like, so in this case, let's say webshop connects to different services, and one of the service also needs information from another service, but they decide to cache PCS title here. This will mean PCS will fail in experimentation because they are not owning the data. So they are not asked by the web shop what title do you want me to show to this customer, for example. Frank, can you recap for me? Were you asleep?
Yeah. No. I was almost asleep. No, so remember, we were trying to solve a problem. We had a problem here with isolation. And our solution was to take things that were physically one thing and we brought them to physically many things. So immediately you get all kinds of overhead that you need to deal with. You get new problems that you need to solve. As I said, every level of abstraction has some associated costs. And in this case, for example, experimentation was a big one. As soon as downstream services start caching something, they can get inconsistent results, or you need to have caches that take into consideration all types of experiments that we're running, and we're running hundreds at the same point in time. So the complexity of solving this at scale is enormous. And before that, it was just in memory, one app, very little overhead. So it's a trade-off. But a lot of teams became autonomous. So what we see is that with spinning up more and more tiny services, the complexity grows in terms of running it, but also of interacting with other systems. So it's not really like that, the case that if you take something apart and the product owner now has some autonomous entity, that autonomous entity lives in isolation, right? It doesn't. I mean, it doesn't live in a vacuum. Whatever you took out still is dependent on its context. So you still need to actually align on all these kind of changes. So those kind of problems did not at all get solved by introducing microservices. What did happen is that the technical overhead became way bigger. And organizationally, well, it's actually, you could wonder if the problem didn't get worse. Because we had like X POs on a certain monolith. I think you can do X times N POs because we have X times N services. So the amount of alignment that you need to do also grows. And for everybody who has been known to work in a monolith and then all of a sudden went from like 2 monoliths that talk to each other to whatever, 700 microservices with 4 layers of microservices. I mean, figuring out what goes wrong where, it's a monumental task. I mean, the cognitive overhead for people is huge. And again, everything that you spend on dealing with that overhead, you lose in time of innovation. So architecturally, I'm not really sure we solved a lot. So, yeah. So if you look at how we broke up things at Bol, it started in a monolith and everything was fluid. Everything was basically touching each other. It's very easy, right? You have a code base, you need something, oh, somebody else already implemented this, I'm just gonna inject that bean or whatever, I'm gonna interact with it and yay, problem solved. This made it very hard for us to take things apart. Then the other thing we saw, so migrating there, I mean, was very hard. So then the other problem that we saw, in Bol we introduced something we called products, right? Alexandra already referred to it, so we try to logically group stuff. But you cannot simply group things in a way that you get equally sized products. So what we ended up with is, well, some products that was really like a domain-driven entity or a nice formulated cohesive domain, but you have some who are just everything that is left. And that makes it very hard to do some nice domain-driven design. Then the second thing is, okay, at first you take things apart and you're already happy it's apart. I have my own application, my own code base, can deploy it on my own, woohoo! And then all of a sudden you realize that the whole world has now connected to you just like they did in this monolith. So all these things that were first in memory and were fast are now all of a sudden a public API that everybody can connect to. I mean, at first we were just happy to take it apart. So we really didn't spend much time on managing who got access to what. And better yet, we just took a domain, we deployed it, and our internal API became our public API. What could possibly go wrong? Yeah, so, I mean, autonomy, the real autonomy doesn't really exist in these circumstances, right? Autonomy exists in a vacuum. I don't care about anybody, nobody's calling me, I'm not calling anybody, then you're autonomous. But your service always has value to add to the company, right? If the system has no input or output, it's useless. So you need to interact with people, and how we want to isolate us, or the way we isolate ourselves as much as possible, is that we define a contract on the outside. And then another brilliant thing happened. Basically, the level of abstraction that we had was just not right. So we started thinking, okay, this is like a separate business entity, and we're going to separately deploy it. Separate code base, separate pipeline, separate deployable. So something that could be a cohesive, coherent API with one deployment became 10 deployments. Now, if you now remember how it is in a bakery to have a cake baked, I mean, it goes really far, right? So all of a sudden you don't get a cake anymore, but you get 2 grains of salt there, 2 grains of there, you have a bit of X here. So if you don't think about the bigger abstraction that you're trying to implement in your company, if you don't think about the right domains, taking things apart will make it much worse than it was before. And this is the fun part. So the reason that we went from monoliths to microservices was actually that everything got intertwined and that we were not autonomous. And the problem behind that was that we're humans and we're not really good at designing stuff. So the idea that going from a monolith to microservices solves problems that are inherently people problems is point blank retarded. But that's not the only thing that happened. So we went into the cloud. We went into microservices. So, I mean, there's a certain, let's look at society, right? There's 10% that's super talented, and there's like 90% that's a little bit less talented. Or something. So the point here is that if you do not educate the people that you have, right? You come from the university or from whatever kind of education you had. If you don't teach people to become really good developers, they will just learn by looking at the context they're in. So if the context is not something that makes a lot of sense, everybody will be taught the wrong things. Right? So if you don't invest in craftsmanship, if you don't invest in making people really good at their skill, and you venture into monoliths to microservice, where you also don't know what you're really getting into, this creates an exponentially growing problem. So we went from 10 deployments with 100 developers to about 1,400 deployments with 700 developers. Which is kind of fun, because apparently all of a sudden we own now 2 deployments per person. So in terms of operational costs that are associated with this, it's just crazy. Let's say Spring Boot updates. And you need to do 1,400 applications of updating. Just imagine the man hours that you need to spend to do that simple task. Eh? So the ratio change is just insane. But we didn't pay any attention to this, right? We're on a mission. We're creating microservices. We're taking everything apart. The smaller, the better. So we got only of many. So the technical development time overhead is intense. And then this time, it's no longer Maurice, our other co-host, but it's Alexandra who will tell you something about how we saw problems arising on the technical level as well.
Yes, thanks, Frank. So we started looking into numbers. We first looked at how many instances most of our applications are using, and we noticed really most of them use only 2 instances. Why we were so interested in this? Because we really thought one of the actual needs behind this decision of creating a new microservice is actually a scalability need, you know, but apparently from the numbers that we have now, it's not the case. Then we also looked at the amount of CPU that we are using, so only for the JVM. Most of the applications are 0.1 CPU, so again, we were quite surprised. You know, we expected some really big applications or something. No, really small applications, tiny features, tiny code, actually. And then we also looked at the memory, and indeed, we saw some differences there, but actually these are the applications with the maximum heap. Again, quite some applications that have very little memory allocated. So our observations and hypotheses, services are actually small at Bol, based on the resource, of course, usage. And most of them really don't need horizontal scaling, why we thought people implemented it or made the decisions like that way. Then we also looked at the network. Of course, small services require more network calls. It's really different when you go from a monolith to tons of services that need to communicate among each other. So we thought, let's tell people that this is quite expensive, not only in costs of, let's say, GCP, but also what we need to do to have it this way. So let's break down the cost, client and server. You need to implement it, right? The integration between. I think this is probably the most expensive part in actually setting up a network call. So on both sides, it's really costly to implement this within the teams. Every service needs we don't also have structure in it, so everyone is like finding their own ways, implemented differently. Then there's a lot of configuration involved to make the call work. Resilience, monitoring, authorization, of course, alerting, so a lot to do there. Doing all this can be quite time consuming, so not only costs in money, but time, which is also translated to money eventually. So then every call costs a lot of resources as well in terms of CPU and memory. Finally, everything you build needs to be maintained. So that's also an overhead that teams are feeling at the moment with so many connections between the services. So what we concluded is that small services have more network overhead. It's a really different story if you need to go from A to U in terms of the overhead. You shouldn't be just looking at one or two services, but you should really look at the whole of your landscape. In terms of application, we said, let's try to put some numbers on this as well. So how much do we actually consume for a base, and what's the application-specific code? So we visualize it like this is an empty application, that's the base. This is a small application, this is a big application. So because we have so many small applications, it actually translates to a lot of base overhead, right? It's not that much the base overhead, several hundreds megabytes probably, but still, if you multiply it by 1400, that is a growing cost each year if we continue in this direction. Plus, we also have some infrastructure overhead. We use Istio Envoy proxy, and we also use the Prometheus scraper to scrape the metrics and then send them to the metrics platform. So, for instance, the Istio Envoy proxy, I think it's around 65 megabytes, but still something to add in the whole puzzle, you know? Yeah, and like Frank mentioned, there is something with the maintenance overhead. You need to update so many dependencies, you need to update framework, library, R2D2 is our provisioning tool, you need to update that 1400 times. Preparing for the season, access management, sleaze, slows, SRE stuff, so it really gets a lot. And it wouldn't be really such a big problem if you do it once or twice, but we noticed that people get this fatigue from keep updating all their systems. It doesn't become fun if you have to do it a lot of times in a team. So we have teams that have, for example, 40 microservices with 3 or 4 people, you know. This really doesn't get more fun than this. So this was the part about the overhead that we saw in network and application. And now I want to hand it over to Frank for the closing part.
Oh yeah. You think closing, that's going to be quick? No, it's me talking. So clearly we had growing pains on a technical level as well, right? So growing pains on the technical level are both really with technique, but they're also with people dealing with technology. I mean, everything that you run in the cloud or on any DC has its costs. So if you make everything smaller, by ratio, the overhead gets way bigger, right? And by that overhead, the amount of money you need to pay for overhead is also much bigger. So you got this huge collection of tiny overheads. On an operational level, you can imagine that if you have 40 microservices instead of one bigger service, that the amount of the cardinality of your metrics goes through the roof, because usually we have metrics on a per node and a per deployment basis. So and people don't think like that. They don't feel like that, right? People think like, okay, this is the way I was taught. Microservices are good, monoliths are bad. And that's really how people reason, and they don't even question or challenge these ideas. So this maintenance overhead, I mean, updating, so we have something that's wrapped Terraform, so we can manage our cloud resources easily. So every time that updates and a major version, everybody is busy. If you have, and we have that per Kubernetes namespace, so if you have 14 apps with 14 namespaces, you have 14 times this freaking upgrade tail. And you have that for every kind of major tool that has a release cadence that does 1 or twice a year a major version bump. Spring, I think, does it 1 time a year, but then still with 14 services, it's more than a chore. And this puts pressure on developers, and pressure on developers also at time becomes like, it has an impact on the feeling of well-being, right? People want to be productive, and they don't feel productive if they're just upgrading something that is not necessarily, where it's not necessarily clear what the value is of the upgrading they're doing. It's hard to motivate for people, and this in turn causes that fatigue that Alexandra was talking about. And again here, the time that you spend on understanding your systems, the time the cost that we make on running the systems, everything has impact, right? The costs impact the people you can hire to do more things. The time that you spend on things that are not really directly bringing innovation or value to a customer, you cannot, it's also costly. So both technically and architecturally, we've gained something, but if you take stuff to the limit without really reasoning about it up front, it is really negative in its impact. And clearly, I mean, it was way cheaper to run a couple of big monoliths than it was to run all these microservices. Because now, all of a sudden, we need distributed tracing. We have it by now, by the way. It's misinforming people. No, but I mean, and that's really expensive, right? If you need to start sending traces of a vast microservice landscape, which still does, unfortunately, a lot of their operations synchronously, the amount of traces you'll be sending with a certain request volume is amazing, right? I mean, then you,
it went live last week just to make it.
Yeah, but it is live. So, but here we go. Okay, so it's also here. We need to invest in a solution that is due to a problem that was triggered by a solution, which kind of makes the whole thing a bit iffy. So we started using Spring Boot a long time ago. We have an internal application framework called Axel, super successful. And there we use just a spin-off of the Spring Boot initializer, the Axel initializer. And this beautiful thing makes the assumption that you have a deployment and a namespace, etc., per app. And an app usually starts with one module that has business logic. So that we made it easy to start your own app was part of the reason that we actually ended up with so many microservices, because people did this, click, deploy, et voila. But also with R2D2, that's basically our wrapper around Terraform, it made it also too easy to create many namespaces, to create many Kubernetes namespaces, etc. So self-service, if done without thinking about the impact, can be harmful. And we had some naive standardization going on, clearly. We were only thinking about productivity now, but we never thought of productivity then. So we're very short-term minded in that thing. So we had a focus on capabilities. So Scrum teams usually, and their product owner or product manager, they're focused on delivering stuff, right? They want to add value. POs got KPIs or whatever, and they need to deliver on that. Well, they rather make it happen so they can say that they are delivered, and the team by proxy feels this pressure to deliver these things often. So what you get is that the team is focused on delivering that feature and doesn't really take the time, or perhaps even have the time, to zoom out and look at things from a distance and think, oh my God, what have I done? So this focus on capability, adding capabilities, is also detrimental. So we're also looking at another organizational problem here that fed into this microservice mayhem. New technology. So who here is using Kubernetes? So who thinks he or she has mastered Kubernetes? Yeah, so this is kind of the thing, right? Because it has a massive learning curve. Like if you really want to figure out how Kubernetes works, you need to spend a lot of time. But we didn't have time. There's the cloud, go for it. So everybody learned the bare essentials from this new tool. This is logical, and again, I'm referring to the thing I said before. If you don't educate people, if you don't give them the time or invest the time to help them with their learning curve, help them grow their craftsmanship, well, then you are in the cloud and you have 90% of the people who have no clue what they're doing. And if shit hits the fan, yeah, then what? So the lack of craftsmanship, huge deal. So one of the reflections here. So smaller is not a goal, right? It never was. Right? The intention was to make us go faster, to resolve some organizational problems and to resolve some architectural and technical problems. The goal wasn't smaller, but somehow in the industry, microservices became like the thing. You don't have a microservice? This is quite funny. So the people who advocated microservices, so basically it was Amazon Cloud and Netflix that started the whole thing. So if anybody who paid attention, there's Amazon Prime is reverting from a microservice architecture to a monolithic architecture because it was too expensive to run. Nice, huh? So there's no free lunch. Every abstraction is costly, period. And we solve problem by adding abstraction because it makes it easy to think. But there's a lot of stuff under the hood, and we need to be mindful about that way more. And then you get this. So we had a solution for the organizational technical problems. So that solution in turn gave another problems. So we tried to fix those problems of the solution, which in turn had other problems, which we needed to solve again. So if you are not aware what you're doing, if you don't zoom out, but are really in the moment continuously fixing the next problem, then you're creating a massive mess. So you need to be able to stop, zoom out, think what's actually the goal that you have, autonomy and velocity, and try to cater in your landscape to achieve that. But making things smaller is definitely not the way to go. So yeah, I lovingly call this problem ping pong, because if you do not watch out, you'll be basically going back and forth, introducing a new problem and a new solution for that problem. And where does this stop? And this, in a bigger organization, is costly, because by the time that you have taught anybody, hey, this might not be a good idea, and that's become part of the DNA and of the culture, that takes years. So if you somewhere along the line took a route that made you less effective, turning back is a crazy endeavor. So what we should do is ask ourselves why. I want to add a new business capability. Where am I going to add it? Build a new service, a new Terraform setup, a new Kubernetes namespace, a new repository, a new build pipeline? Why? So I've been talking to people, and I said, okay, we should just create mono repos. If you're using Maven or Gradle, make a module per separate deployable. Super easy. One build pipeline. If they belong together in the same Kubernetes namespace, perfectly fine. You can just manage the write. They are all already having privacy-related data or not. But security-wise, that's perfectly fine. And then people say, like, yeah, but it doesn't belong there. Like, it's a really hard argument to fight, right? Yeah. Purity in architecture and purity in code is often problematic. And people are taught in school, like, yeah, you should separate everything. So it's super tough. But as soon as you say, okay, you're now going to add a new business capability, you know it's going to be 5 classes to implement it, and then ask people, but is this worth a new namespace, and a new deployment, and a new this, and a new that? Then the conversation is way easier. Like, yeah, there's a lot of stuff for this. So then people feel it. But as soon as you talk about consolidating multiple things into a single thing, then all of a sudden there's a lot of friction. And this is not a problem we've solved, by the way. This involves a lot of talking and convincing. So what we're aiming for eventually is proportionate solutions. So we have a problem domain. We should not go all in with something. We should figure out what works in this specific case. We should figure out to what extent we want to go with things, but not go mindless, like I think the industry has done. And think about cost effectiveness, right? You have a solution, you want to move faster. Why you want to move faster? You want to be able to deliver more value. And why you want to deliver more value? Because customers like that. In our case, they'll probably buy more, right? But if the investment that you did over time gets so big that the added value gets annihilated mostly, or developers walk away because it's an unholy situation to deal with, or it's very hard to grasp, so you can only hire rocket scientists, then what have you just achieved? So the goal is to think about the overhead, look at your own situation. Where can I save money? Where can I save time? Where can I reduce cognitive load? So we can decrease this overhead and in turn increase the time that we can spend on innovation. So that's it. Thank you.